Now that we know about vector algebra, or at least the algebraic representation of a vector, we want to begin connecting things that we already know. So we know that the horizontal component of vector v we saw was given by A, and then the vertical component was given by B, right? Well, previously we saw that the horizontal component was given by magnitude of v times cosine theta, and the vertical component was given by magnitude of v sine of theta. Okay, fine. So we can actually say, A is magnitude of v cosine theta, and B is magnitude of v sine of theta. Okay, great. What if it was given in reverse? Imagine that we know, say that, I'm just going to do an example where we say vector v is equal to, say, 3, 4. Okay, can I get the direction and magnitude from that? Well, let's take a look. Okay, so again, I'm in that scenario where I'm in the coordinate plane and I have the initial point and I have the terminal point. Okay, there's the vector v. Okay, and I can break it down and say, okay, this is its horizontal component A, and then this would be its vertical component B. Okay, and how can I figure out, there's actually no vectors above there, I'm sorry. How can I figure out its direction and magnitude? So direction, again, would be this angle here, theta, and then magnitude would be the length of this vector, magnitude of v. Okay, well, I think you're probably looking at this like, oh, well, there's a right triangle, and you're correct. There is a 90-degree angle between A and B. So then our good old-fashioned rules of right triangles work. We know, Pythagorean theorem, we know sine, cosine, tangent, all that good stuff. So let's see. So if I want to find magnitude of V, I can say, okay, that would be the hypotenuse. If I square that, that's equal to A squared plus B squared. Okay, so then just square root both sides. Magnitude of V is equal to square root of A squared plus B squared. Now, technically, there would be a plus and a minus in here, but we're talking about the length of a vector. Length is a distance, which is never negative. So we just have to go with the positive there. Great. One problem down, another problem to go. I want the direction. Okay. Now in my diagram, this would be given by theta, and actually I'm going to call it theta prime. Um, theta prime. And then because it is an acute angle, and so to find theta prime, I could say, okay, well, I'll come back to filling the rest of that equation in a minute, but if I do tangent of theta prime, that would equal b over a. Now, at this point, I could do sine, cosine, tangent. I get that, but remember that b and a are given to you, so use your given information. So then to solve for b and a, this should be theta prime is tangent inverse or arctangent of b over a, okay? And because tangent can give you positive or negative values, I'm going to put this in absolute values. Technically, you would get an acute angle, or since theta prime is acute, you would get a positive angle. And then you don't have to worry about absolute values, that's fine. But more generally, when you work with your direction in general, that is theta, you do have to worry about the absolute value. So I'm going to say it's going to be your direction, your general theta, not theta prime, is going to be tangent inverse of b over a, and then absolute values of that plus adjusting to the quadrant. Okay, we have an example coming up and I'll show you what I mean by that. But technically, what I want you to do for the direction is calculate tangent inverse of b over a, do the absolute value, that's fine, and recognize that that's your reference angle. Okay, this is a concept we haven't seen in a while, but this is your reference angle, and then in a particular quadrant. So to find your overall direction, your theta, find the reference angle and adjust it based on the quadrant. Okay, so big takeaways here. Magnitude of v is going to be the square root of a squared plus b squared. Okay, that one's easy. Theta prime is tangent inverse of b over a in absolute values. Okay, and then the direction is theta prime plus adjust to the quadrant. Okay, so we're going to make use of these formulas in the upcoming example. Okay, so suppose v is this, determine the magnitude and direction of this vector. Okay, now before we begin just going right into the equations, I'm going to say, okay, let's make a little sketch. Okay, so I'm going to say this is -5 and this is +3. Okay, and so I get a vector right there with where its terminal point is there, and I'm assuming in this case that the initial point is at the origin. You can always make that assumption. That's a fair assumption. So we have something like this. This is vector v. Okay, and so we can find the magnitude, right? The magnitude of vector v is just going to be the square root of the horizontal component squared plus the vertical component squared. Okay, square root of 25 plus 9, square root of 34. Okay, a yucky number, but hey, it works. Okay, now in terms of the direction, okay, this is where we need to be a little careful. Normally, I would say that this theta, this is our direction. Okay, but what I'm actually going to be able to calculate, again, this is A, this is B, is I'm going to be able to calculate this angle here, which is theta prime. Okay, and so to calculate theta prime, this is where I have to do the absolute value of tangent inverse of b over a. B is 3, and a is -5, okay? And I'm going to get a number. And that number specifically is, let's see, inside here it's going to be negative, let's just call it 31 degrees. It's pretty close, okay? I'm going to say approximately -31 degrees. Okay, so in all my reference angles is going to be, say, 31 degrees, approximately. Okay, so I know what theta prime is. Then to calculate the direction, I have to take theta prime and adjust it to the correct quadrant. So since I'm in quadrant 2, the direction is going to be 180 minus my reference angle, because I'm 31 degrees above the negative x-axis, which is 180 degrees. So then doing this arithmetic, I believe I end up with 149 degrees. Okay, so that's what I mean by find theta prime using tangent inverse of b over a, and then adjusting it to the correct quadrant. Okay, sometimes, particularly if you're in quadrant 1, you are just fine if you do the angle or your direction as b over, or tangent inverse of b over a. But I think this is a more general case where we have to, do a little bit more geometry and work through some finer details. Okay, so big takeaways: we know magnitude of a vector is square root of a squared plus b squared, where a and b are the horizontal and vertical components of a vector. Direction. Yep, we have to find the reference angle, which is absolute value of negative b over a inside of a tangent inverse, and then adjust that reference angle to the correct quadrant. And then we should be good to go to find and describe a vector algebraically.